By the Middle Tempocenic, the live-bearing fishes have diversified enormously. From tiny colonists have radiated an enormous number of new lineages. Guppies gave rise to dozens of distinct freshwater lineages, ranging from small, minnow-like shoaling species to truck-sized riverine herbivores that may consume more than 400 pounds of green food in a single day, and give birth to as many as 100,000 free-swimming larval offspring in one litter. They give no parental care, and even though they do not lay eggs, they still rely entirely on chance to reproduce, and play the numbers game in hopes that one or two of their tiny infants will survive to maturity. For they contend with an onslaught of countless, fierce new predators. From the Pleiades and Swordtails have arisen the Swordsharks, lively shark-like carnivores with frightening, toothy maws that teem across all of the ocean's salt waters. With highly elongated tail swords in both sexes, these fast-moving oceanic fishes use these to sweep through shoals of fish, stunning them, and then turning around to gobble up the casualties. With complex social behavior, swordsharks are cooperative hunters, teaming up to trap fish in bait balls with nowhere to escape, making feeding easier. To facilitate communication between individuals, they can rapidly fire up or dull down a series of bold spots on their sides, which reflect light and make their positions clear to their fellows. These fish have also evolved a placental tie, with which they nourish their young in the womb, thereby giving birth to fewer but larger offspring, each better suited to survive on its own after birth. Adults move towards shore, giving birth in sheltered, floating algae thickets, where the young are safer than the open sea. The opaline sword shark, Encephalocotix opalorica, is an 8-foot-long predator of the open Serina seas. A typical member of its grouping, these fish hang in loose packs and work together to attack shoals of smaller fish, threshing them with their tails to stun them. On warm, tropical mudflats, the bizarre mudwickets, small but oddly shaped creatures with squat, toad-like bodies, bulbous eyes, huge mouths, and flattened bellies, hop from the tide and onto the shore to hunt seaside insects and crustaceans with needle-like teeth and oversized, crunching jaws. Only very distant relatives of the sword whales, these fish descended not from the swordtails but the guppies, and their evolutionary history has been very different as well. They have largely left the sea and crawl about on the sand with webbed, hand-like pectoral fins and periodic thrusts of short tails, which function like a spring to catapult them to safety in times of danger, and survive above the water by absorbing atmospheric oxygen through a highly vascularized plate on the roof of the mouth, and to a lesser extent through their skin, in a manner similar to amphibians. So long as these structures remain moist, they allow the fish to survive indefinitely out of the water, Mudwickets are terrestrial from birth, able to breathe air from infancy, and will drown if trapped for a prolonged period in deep water. Their gills diminished and their swim bladders vestigial, they can no longer swim. Instead of retreating to the water when danger threatens, they rush to complex, communal burrows just below the high tide line, which may extend 5 feet below the ground and consist of a series of flooded chambers. Every chamber in a burrow holds a large air pocket, which can only be kept fresh and oxygenated through strenuous, repeated trips back and forth to the surface at every low tide. The fish bringing up a mouthful of depleted air and then back down a bubble of new, clean air with each descent to fill its reserves. These air pockets keep the fish alive when high tide returns and covers the burrow system in as much as 4 feet of water. The mudwicket's burrows may be used as many as 200 fish at any one time and can become quite complex. Different chambers are utilized for different purposes. The deepest chambers are for the storage of excess food, which lasts longest in relatively low oxygen, cooler conditions, while the warmest, most oxygenated, shallow chambers near the surface are used as nurseries in which they give birth. The infants are large and well developed when they leave the mother's body, but remain underground for a considerable time before ever leaving to hunt on their own, being fed by the colony's adults. This appears to be an unintentional effort, the mudwicket having a tendency to drag its prey underground before feeding, primarily to prevent it being stolen by a competitor or attracting a predator, thus allowing the young to gather around and feed on the scraps. The young mudwickets will remain underground while growing fat on their parents' scraps for as many as 30 days before they emerge from the burrow for the first time to hunt on their own and begin to pull their weight in maintaining the burrow. Individual colonies of mudwickets are male-dominated, and these males, which are large and brightly ornamented, are fiercely territorial toward their same-sex neighbors. But as a colony grows, a single male cannot possibly mate with as many females as he might control, giving males on the outskirts of the colony without harems their own chance to mate when the females come above ground to feed. Young males are driven from the colony at maturity, the lucky few to survive long enough to start a new burrow system, beginning their own new harems and colonies, the rest surviving in only small shelter burrows, and relying on sneak mating to mate with other males' unguarded females to spread their genes. When a predatory bird threatens, every fish on the shore will vanish in an instant into the sand and seal the entrances of their burrows with a plug of mud until they are certain the threat has vanished. It is not unusual for a colony to remain entirely underground for an entire day after a fright, feeding on the invertebrates they have amassed in the lower chambers of their burrow system until they can be certain the danger has gone. Most of a mudwicket's diet consists of insects, hermit crabs, and other arthropods along with the occasional small fish trapped within a tide pool, though large species may occasionally ambush small birds. One genus specializes in bivalves, making regular forays down steep rocks into deep tide pools to pull them from submerged stones, then crushing the shells with enormous squared-off teeth to get at the meat. Conversely, another has evolved to forage quite far up the beach and away from the surf, having abandoned colonial existence for small and solitary burrows near the tree line at the end of the beach, which just tap the underground water table. One particularly promising family of mudwicket has, in fact, left the seaside environment completely and moved far inland, following rivers and building its burrows in the muddy banks of freshwater ponds and streams. Here, they prey on crayfish and aquatic insects, as well as land invertebrates such as crickets and snails, that they may forage for as far as 50 meters from the water, crawling through damp leaf litter and even scaling small logs and fallen branches in the process. In rainy conditions, members of this group may travel over a mile inland to reach isolated sources of water, digging into damp soil or hiding under logs to keep damp in between open pools of water. Most solitary inland species are colored cryptically, but a small number are extremely vibrant and impossible to miss in shades of blue, red, and yellow, advertising deadly toxicity in the mucus of their skin that they engineer from their diets, which incorporate a significant amount of poisonous ants. The seven-spotted mudwicket, Rhinocephalus septilochus, is a plump, colonial species of mudwicket that thrives along the seashores in tidal estuaries of the Sierran subcontinent, where it dwells in large and complex burrow systems just below the high tide line. In most mudwickets, males are larger and brighter than females, but females too, in some species, can carry some bright colors, and a female carrying a litter of offspring can become quite swollen in the days before pregnancy, rivaling the weight of her mate. Most species, even at their extremes, are hardly what could be considered large, except on a relative scale, however. The seven-spotted mudwicket is an average 6.5 centimeters in length and just 1 to 2 ounces in weight. Though a descendant of the extravagant guppy fish, their tails today, short and stocky, function for little more than an occasional boost of propulsion to dart down a burrow to safety. The grandest guppy. Meet the Gemnus. This is a guest entry conceptualized by Joseph Cowley, who commissioned the project author to illustrate this species to flesh out the project. His writing below has been supplemented by the project author for clarity. In the mid to late Hypostacene, the freshwater ecosystems of Serina have stabilized and diversified into rich environments full of diverse plant and animal life. Freshwater habitats presented excellent opportunities for speciation due to the constantly changing environmental conditions as rivers twisted and turned, connected and disconnected from ponds and lakes, and moved toward the sea. As with all life introduced to Serina, the evolutionary vacuum also had profound effects on the live-bearing fish that were seeded in Serina's waters, which diversified dramatically to fill the niches of an empty ecosystem. From the late Hypostocene to the early Tempucene, many lineages of guppies evolved to exploit all the vegetation that formed the basis of these new aquatic food chains. Many new families evolved that were either entirely herbivorous or whose families had representatives that fed predominantly on plant life. In the tropics, this explosion in herbivore diversity can be most plainly seen. Here, one can find fishes straining the surface for tiny leaves of water lily-like floating clovers, others that scrape low-lying algae off rocks, filter feeders that strain for the smallest of phytoplankton with gill rakers, bottom-feeding forms which scour the mud on the bottom for edible detritus, and finally leaf croppers who browse the larger macroalgae, elodia, and aquatic grasses with blunt, cutting teeth. Even species that fed on similar plant or algae species could avoid competition with each other by feeding at different times of the day, or in the case of large, upright aquatic plants, could have different species exploiting them at different depths. When these herbivorous fishes first evolved, a veritable bonanza was available to them. Snails and crayfish, among other invertebrates, fed on Serina's plant life since the beginning of Serina's history, but they were not especially mobile. Fish, meanwhile, were able to move much further into new ranges in a single generation. They could, in most instances, also grow larger, allowing them to become the primary herbivores in aquatic environments within just a few million years. Though Serina had several entirely aquatic plants introduced at its start, terrestrial species quickly also adapted to survive and even thrive in riparian environments and eventually in fully submerged habitats. Grasses were among the first, producing several aquatic lineages in the first 10 million years of evolution on Serina. With sturdy leaves protected from many grazers with silica particles in their tissues, grasses were tough to consume. Some guppies grew larger to consume them. They evolved pharyngognathy. This is when the left and right pharyngeal tooth-bearing bones in the jaw fuse together to form a more sturdy jaw structure able to chew coarse plants. Various muscles strengthened around these throat jaws to enable a wide variety of movements of both the upper and lower jaws and provide a wide cutting bite. Wide, cusped teeth evolved to process aquatic grasses, which they were continuously replaced as the silica found within them wore them down, while symbiotic bacteria in stomachs and guts made breaking down cellulose and other formerly indigestible elements of this diet possible. As happens in any evolutionary race between predator and prey, plants adapted in turn ways to reduce the damage inflicted by these herbivore fishes. Some plants and algae simply grew at enormous rates, able to recover and endure even heavy grazing simply through rapid proliferation. The cell walls of some descendants of Elodia became composed of ever more complex polysaccharides that made extracting energy difficult. Algae developed mineralized, coral-like forms as protection from the algal scrapers. Though life in water usually means plants are free from the need to have sturdy supporting stems, heavy grazing encouraged the development of more rigid, even woody, stems to make aquatic plants resistant to attacks by nibbling fish, while hooks, thorns, and spines were also deployed on a variety of aquatic angiosperms, anything to make feeding on them more difficult. By the Tempocene, many water plants have adopted strange and bush-like growth forms, creating dense thickets of woody stems underwater, which were difficult for most fishes to consume. Aquatic grasses, meanwhile, spread wildly with long, well-defended, silica-infused leaves, sharp enough to cut unwary swimmers by. Never had Earth ever known such a viciously defensive underwater ecology, because never had Earth provided the environmental conditions to allow for the evolution of large numbers of huge, plant-eating freshwater fish. But not even the most vicious defenses can dissuade the largest and most specialized of these grazing fishes evolution could produce. Originating in the tropical rivers of northern Kari, one group of guppy descendants, known as Gemnuses, evolved as veritable living lawnmowers, able to get past even the most vicious plant defenses. Bulky herbivores with well-developed pharyngeal jaws for slicing and grinding up the toughest plant material, while their intestines are incredibly long, often 15 to 20 times that of the body length. These adaptations together enable them not only to extract as much nutrients from some of the most well-protected plant life around, but to specialize upon it. Because they favor the harshest plant diets, they have little to no competition and can grow to quite large sizes, with the smallest being no less than 10 feet long. As far as guppy clades go, they are not the most diverse by any means. Just 12 species exist worldwide, but their large size and continuous browsing on vegetation makes them have significant impacts on the ecosystems they inhabit. By the middle of the Tempocene, one particular species of Gemnus has evolved to grow to truly extraordinary dimensions, surpassing any freshwater fish of modern Earth. Native to the deep, vegetated rivers throughout the continent of Canary, it is notable for its opportunistic grazing over land when seasonal rainfall causes the rivers to overflow their banks, at which time the Gemnus takes advantage of the situation and grazes these submerged grasslands much like an underwater cow. The giant Gemnus can grow just over 30 feet in length and is truly an awe-inspiring sight to behold. Weighing over 3 tons, these truck-sized fish are true titans of the river. They are endless nomads, traveling up and down the waterways that they call home. They feed predominantly on a particularly vicious-looking plant, spike-leaf waterweed, a spreading, fast-growing aquatic grass with knife-like leaves edged in barbs of silica deposits, which it evolved in response to millions of years of grazing pressure by smaller fishes. When left to themselves, these plants quickly form impenetrable thickets along the riverbeds and are quick-growing, covering the water column from bottom to surface. They shelter large amounts of small fish and invertebrates when present in moderation, but if left entirely undisturbed, colonies of this plant accumulate sediment in their spines, causing rivers to gradually become clogged with dirt, shallow and muddy, eventually becoming shallow marshlands where little plant life but the spike leaf can survive. Once the river fills with sediment and becomes too shallow for the few aquatic species that can eat it to reach it, virtually no terrestrial grazers exist adapted to consume it, and huge stretches of wetland can become clogged with it to the exclusion of most other life. Fortunately for the health of the ecosystem, Gemnuses have evolved to browse the waterweed heavily, consuming it preferentially during the drier seasons, when the rivers are lower and the grasslands above dry out, and preventing it from congesting the rivers and dominating the riparian landscape. They have large, heavy scales for protection against the spines covering their face, present even on the lips. Their teeth are multi-cusped and have additional serrations on each cusp to maximize the surface available to chew. Due to the intramandibular joint that it has inherited from its guppy ancestors, it can gape wide and has increased bite force, allowing it to take huge bites out of a thicket of these well-armed plants. While the plant is being sliced up, the insides of its mouth produce copious mucus to protect it from the spines piercing its mouth. It is the mighty pharyngeal jaw with rows of elongated, molar-like teeth with a ridged surface used for grinding the plant into a pulp that can then be swallowed. Able to consume more than 400 pounds of plant matter daily, even a small population of giant Gemnuses serve well to limit the growth of the spike leaf and maintain a healthy balance of microhabitats in the river. Clearings formed by the grazers allow water to flow freely, preventing sediment from building up, while remnant patches of the plant proliferate in shallow bends and eddies that the largest grazing fishes cannot reach, sheltering fry and invertebrates from their predators. Giant Gemnuses are very long-lived. They reach sexual maturity at 15 years of age and can live as long as 120. And though growth slows after the first 20 years, it never entirely stops. Traveling up and down thousands of miles of rivers their entire lives, giant Gemnuses are solitary but not territorial. Mating is a sporadic occurrence which can occur at any time. When two of these giants encounter each other, they will line up beside each other. The sexes are identical, save for the gonopodium of the male, so they each inspect the anal fin of the other. If this fin is the same shape as theirs, then they will continue on their path. But if the anal fin is a different shape, then mating will commence. There is no elaborate courtship as for the most part, as adult giant Gemnuses are rare, and to even encounter another one is a good indicator that that individual has lived long and has good genes for survival. If multiple males meet, they do not fight. Both will mate a female in turn without aggression. Several weeks after mating, a female gives birth to an incredible 100,000 or so young, which are shockingly small in comparison to herself, barely a centimeter in length. This shows very clearly that the Gemnus lineage has evolved enormous adult sizes quickly and without any modifications to the ancestral guppy's manner of reproduction, where small eggs hatch internally and are then birthed and left to their own devices. The young experience overwhelming mortality in their first several years, and less than one brood can be expected just through its first 2 years. Possibly as few as only one individual in every 5 million born will manage to reach its maximum size. The young hide in the weeds like the fry of other live-bearers and initially eat biofilm, algae, and the larvae of insects. There are numerous predators ranging from bass-like group fishes to small mantis-like fishing crayfish waiting for their chance to strike. And some Gemnus live for just seconds if their mothers do not take sufficient effort to shelter in the weeds when giving birth. If she does not, other fishes will swim right up to the oblivious birthing mother, waiting to be the first in line to catch the fry as soon as they emerge. When the survivors of the initial gauntlet reach a length of 4 inches, their jaw changes position from terminal to ventral, enabling them to graze algae off the leaves of large water plants. Now, they are a little safer as they are faster and more alert and can zip to shelter if danger approaches. When they reach a foot in length, their guts become increasingly well developed, and their mouth and throat teeth become more suiting for nipping off and chewing blades of grass. Though it will be some time yet before they can consume the spike-leaf plants the adults primarily eat. At this age, the juveniles will begin to venture into flooded meadows and crop the submerged land grasses. And while they have outgrown some enemies, many large predator fishes will still take them. By 5 years of age, however, the ever smaller pool of survivors will have grown to a length of 10 feet, outgrown virtually all enemies, and begun feeding on spike-leaf plants, effectively adults. They are now big enough that little can bother them, and they start to become solitary. Their sharply forked caudal fin becomes more rounded for their more lethargic way of life. From here, the only further changes are gradually increasing size. For decades they grow, albeit slowly. The bigger they become, the better they can digest their coarse diet. But eventually, in a cruel twist of fate, they all outgrow their rivers. A dry season might bring the end. The water will, if only temporarily, recede just enough to leave the very largest Gemnuses beached, unable to free themselves, and eventually to starve or suffocate. When a Gemnus dies, it serves as a great feast for a multitude of scavengers that can last for weeks, much like a whale fall in the deep sea on Earth. From birth to death, the gentle giant was a vital part of the ecology of the many rivers all over Kari where it dwelled. Vital to sustaining the health of the large rivers in life. In death, it returns all it has taken back to the environment in one enormous return of nutrients, which may be taken up ultimately by the spike-leaf waterweed, and so in turn feed other, future Gemnuses in the ongoing circle of life.